let's have a look at laws of indices. So, there are three basic laws of indices, which is when you have a base number, so let's call that x, and we raise it to a power, and let's call that a. If we have the same base number raised to a different power, all we do if we're multiplying those two base numbers together is we keep the same base number and we add the two indices together. If we have a base number raised to a power and we divide the same base number raised to a different power, same principle, we've got the same base number, but this time instead of adding we subtract them. And the third main rule of indices is if we've got a base number raised to a power and we raise that to a different power, we're in effect raising everything in the bracket to that positive power. So let's say we've got the same base number and this time we do the a multiplied by the b because it's outside of the bracket. So we're going to multiply those two base numbers together. Okay, so we've got m to the power of 2 times by m to the power of 3. My base number is exactly the same. So all I'm going to do with that is I'm going to take the two index numbers and add them together. So I've got m to the power of 2 plus 3, which is going to give me m to the power of 5. Have a go at the other three examples if you want to pause the video now and have a go at B, C and D and see how you get on. Okay, let's see how you got on. So the next one, m to the power of 3 times m to the power of 3 is going to give me m to the power of 3 plus 3, which bit would be m to the power of 6. C, m to the power of 6 times m to the power of 2 is going to give me m to the power of 6 plus 2, which is going to give me m to the power of 8. And the final one, m to the power of 7 times m to the power of 3 is going to give me 7 plus 3 on the indices, and that's going to give me m to the power of 10. The second law, when I'm dividing index numbers, I've got my base number of n to the power of 5 and I divide by n to the power of 2. So all I'm going to do is I'm going to subtract the index numbers together. So n to the power of 5 take away 2 is going to give me n to the power of 3. Again, if you want to pause the video, have a go at the next three examples, B, C and D. Okay, so let's see how we got on. N to the power of 8 divided by n to the power of 3 equals n to the power of 8 subtract 3, which gives me n to the power of 5. Question C, n to the power of 9 divided by n to the power of 2 gives me n to the 9 take away 2, which is going to give me n to the power of 7. And the final one, n to the power of 7 divided by n to the power of 5 gives me n to the 7 take away 5, which gives me n to the power of 2, or n squared. Now if it's written in a fraction form, similar to what you can see on the screen here, it is exactly the same as writing it out a to the power of 5 divide by a to the power of 2. So these are exactly the same as the last law that we've just looked at, just written in a different format. It's written in a fractional format. So again, we're going to do a to the power of 5 take away 2, which is going to give me a to the power of 3. So if you want to have a go at these examples, one thing I could just say at this point is, if you just think that index number brings up and takes away, that may be a way of visualizing it a little bit better. So I've still got the same a number, so a 5 to the power of 2. Okay, pause the video, see how you get on. Okay, so a to the power of 9 take away 3 gives me a to the power of 6. A to the power of 10 take away 2 gives me a to the power of 8. A to the power of 7 divided by a. Normal a is to a power of 1, so I'm just going to take the 1 away from that. That's going to give me a to the power of 6. And our last law that we've looked at the moment is, if we've got y or any number, base number, raised to a power, and then it's in brackets and that whole bracket is raised to that additional power, that's like saying a to the power of 5 times y to the power of 5 times y to the power of 5. Okay, now 5, if I had that, I would add those two indexes together. I would do y to the power of 5 plus 5 using our first law, and that would give me y to the power of 10. Y to the power of 10 is the correct answer. So let's go back to our original bracket. 2 times 5 would give me y to the power of 10. So y to the 5 multiplied by the 2 gives me y to the power of 10. Now whether you write it out in full like that, because I'm actually squaring what's inside of the bracket, you can do and use the first law, or you can just look to multiply the two numbers together. So the bracket inside the bracket, the index inside the bracket, and the index outside the bracket. So y to the 3 times by the 2 is going to give me y to the 6. Okay, pause the video, have a go at the next two. Okay, let's see how we got on. Y to the power of 4 by 3 gives me y to the power of 12. And y to the power of 5 times by 4 is going to give me y to the power of 20. Hopefully you got on okay with that. We're going to move on to two different other forms of index numbers, and that's raising to a fractional index and also raising to a negative index. So let's have a look at fractional indexes first. With the fractional indexes, you're going to need to be able to know your square numbers and your cube numbers. Usually it's just squareds and cubes that they'll use at GCSE. Okay, so if that's the case, then check my earlier video on finding square numbers and cube numbers. So if I'm looking at this one, you can see 25, 81, 4, 144. I'm just going to stop there for a minute. Okay, they're all square numbers. So 25 is 5 times 5, 81 is 9 times 9, and so on. Okay, and what raising something to a fraction index means is that we're actually going to perform the root, okay, of that number. So I'm going to put my base number inside the root sign, and the denominator of the fraction I'm literally going to put outside of my root. So in this one, this turns it into a square root, and we know that 5 times 5 equals 25. So the square root of 25 is just 5. Okay. Remember, a square root is something times something equals the number that's under the square root, and these two numbers have to be the same. Okay, so hence 5 and 5. Looking at B then, I'm just going to do the square root of 81 because the denominator is a 2, And we should know that 9 times 9 is 81. So my answer is 9. Okay, if you want to pause the video, have a go at the next two, C and D. Let's see how you got on. So the square root of 4 is going to give me 2 times 2 makes 4. And finally, the square root of 144 is 12, because 12 times 12 equals 144. Okay, let's have a go at the cube roots this time. So this one, we've got a 3 on the bottom of my denominator of my index. So I'm still going to do a root sign, but this time the 3 goes out front of my root. And that's making it a cube root, not a square root. So that means something times something times something is going to equal 8. And these three numbers again have to be the same. So 2 times 2 is 4, times 2 is 8. So the cube root of 8 is going to equal 2. Have a go at F. See if you can find the cube root of 125. Let's see how we got on. I'm going to put my 125 in the root sign and put a cube root out the front of it. So what times is by itself 3 times to make 125? And you should have the answer of 5. This is exactly the same as what we've just done in the last part, but we're going to do it in reverse. So we've got this one here, which is a square root of x. You don't always see the 2 at the front if it's a square root. Okay, so let's say we've got that sign there is a square root of x. Now going in reverse, remember if we started off with x to the power of half, we're going to put the x underneath the root and we're going to put the 2 at the front. So we've got to sort of step it backwards. So all we do is we take our base number outside of our root this time. Okay, and we do 1 over and we take our root and put it at the top. So x to the power of 1/2 is the answer to A. Okay, let's have a look at B. So I've got y, the square root of y. So I'm going to take my y out of my root. I'm going to put 2 over the denominator and 1 is my numerator. So y to the power of 1/2, because remember my denominator stays there. Okay. See if you can have a go at the next two. This one's doing the cube root and this one's doing the quad root. Process is exactly the same. Pause the video, give it a go, see if you get it right. Let's see how you did. So we're taking my A outside of my root. I'm going to do my fraction sign as my index, raising it to the 3rd, and I'm going to put the 1 on the top. So it'll be A to the power of 1/3. And on D, take my y from under the root, put my fraction symbol with the 4 on the denominator, and then just the 1 on the top. So y to the power of 1/4. A little bit more involved on this next one because we don't have 1 on the numerator of these indices. Okay, it's a higher power on the top. So I think what we did to start with, we made it the root using the denominator. So we're going to do exactly that same thing. So we're going to put a root of 9 and it's going to be a square root. Once we've got that, using our first law, I'm going to raise the actual whole bracket to the 3rd power on the top. So if it was raised to 1 power, it would just be the square root of 9, which equals 3. So if we can square root it first to give me 3, I'm then going to cube it and raise that to the top power. So 3 times 3 times 3, and that's going to give me 27. So remember that it's got a 1 inside as a power, and I multiply that out, 3 to the power of 3 is the same as writing 3 times 3 times 3. So if I want to evaluate it, that's what I'm going to do. Looking at the next one, we've got a 2 on the denominator of the index again. So this time we're going to say 4 square rooted raised to the third power. So the square root of 4 is 2, and that's the same as 2 times 2 times 2, and that's going to give me 8. Okay, pause the video, have a go at C and D. So I've got 8 raised to, this time, 2/3 power. So my root is going to be the same as the denominator. I'm going to put a cube root out there. Now before, we've already done this one as 2 times 2 times 2 equals 8. Okay, so we know the cube root of 8 is going to give me 2. And the top number, the numerator on my fraction, we're raising to that positive power. So 2 squared is going to give me 4. So 8 raised to the 2/3 power would give you 4. And on D, we've got 27 cube rooted, all raised to the second power. So 3 times 3 times 3 equals 27. So my answer there is 3. Raised to the square, 3 times 3. I evaluate the answer as 9. Okay, so let's have a look at the next question. We've got a square root of a raised to the third power. Okay, and we can try and simplify this a little bit and come up with a little bit of a tip or a trick for this one. And that is that if we have got anything raised to the square root, remember it's to the power of a half. So if I take my power as, my base number as 8, and I'm going to raise it to the power of a half, that's dealing with the square root. Okay. Now underneath that square root, we've got a raised to the power of 3. So if we now multiply the 3 by the number on the top, which just gives me the 1, okay, I've got a raised to 3/2. Okay, now if we did this one, think what we did last time when we looked at it. Okay, if we was raised that to the 3/2, we're going to square root the base number. Okay, square root the base number. And then remember, we've got to raise that then, okay, to the third power. Okay. Now on the last ones, remember, okay, we were looking at doing that with a normal number. Okay, and we could then square root that out and then multiply it, raise it to that power. Okay. So what we're looking to do, okay, is think, what does 3/2 actually mean? Okay, well, if we think about that as a number, that's 1.5. 3/2 is the same as 1.5. Okay, so if we're thinking about the square root of a to the power of 3, and we end up with a 3/2, okay, what we're doing is we're combining those two things in the sense of a 3/2, which gives me 1.5. So I'm halving the root that I've got. Okay, let's see if we can make that make sense a little bit on the next one. So we've got W as my base. Again, I've got a square root, so I've got 1/2, and I'm raising it to the 5th power. So 5 divided by 2, 5 divided by 2. Okay, pause the video, have a go at the next 3 using the same principle. Write the base, put the denominator on the fraction as what the root is, and then put the power to the letter as the numerator. pause the video, give it a go. Let's see how you got on. So we've got x as our base, raised to the third power, and then we've got 2/3. So 3. 2 divided by 3 would give me 2 divided by 3. Okay. Base number w, I'm raising it to the third power. Okay, so third root. Okay, so that becomes the 3 on my denominator, and then I've got the 4 on the numerator. So I've got 4/3. Okay, 4 divided by 3. And on the last one, I've got m as my base. I'm doing a 5th root, and I've got a square on the top. So that's like saying I'm squaring it once I've 5th rooted it. Hopefully that makes sense. Okay. A little bit of problem solving on this next one. We are trying to find out, and I'm going to do one of each. Okay, we're trying to find out if the base number was 9, what would our index number be? Okay. And if my base number was 64, what would my index number be? So let's think about this. We've got 81. And what would we do if we had to write that as 9? Well, if we square root that, that gives me my base as 9. Okay, how do I get back to 81? Okay, well, 9 to the power of 2 would be 81. Okay, so we need to get to the base number first, and then what do we need to do with the base number to get back to the number we started with? I'm going to go on to question 6 and do A. So we've got 8 this time. So that's my starting point. I need 64 as my number. So I've got 64 raised to the what power would get me to 8. Okay. So I've got to think, well, if I square root that, that would give me 8. Okay, so how do I get back to 64 from this? Okay, I would square that to get me back. Now, 64 square rooted, how do I write that with an index? Remember, I can write that as 64 raised to the 1/2 power. So my base number is 64 in this case. Okay, and I know that I needed to square root that to get to 8. Okay, so 8 is 64 raised to the 1/2 power. See how you get on, pause the video, have a go at BC on question 5 and BC on question 6. Okay, let's see how you got on. So I've got the number 3 and I need to raise it to 9 to the power of something to get to 3. Well, if I square root 9, that's going to give me 3. So how would I write 9 in the square root format? It would be 9 to the power of 1/2. So that's B. Let's look at 27. I've got 27. And remember, this time I need my number to be 9, my base number to be 9. So I can't get to 9 using indices very easily from there. But if you think, if I cube root that, that will get me to 3. And then if I square that, the 3, that will get me to 9. Okay, so I've got 2 functions to get me there. So if I think of cube rooting and then squaring, what do you think my answer would be? I've got 9 raised to the 3 over 2. So I'm square rooting the 9 and then I'm cubing it. Okay, So I'm square rooting the 9 and then I'm cubing it. So it'd be 9 raised to the 3 squared. That's 3 over 2. So question 6. I've got the number 4. It needs to be 64 raised to a power on this one. Okay, so how do I get from 4 to 64? Well, I need to cube that. Okay, so if I cube that, that will get me from 4 to 64. So if I cube root 64, that's going to get me down to 4. That's what I want. Okay, how do I write 64 raised to an index that shows a cube root? 64 to the 1 over 3. And 16 this time, similar to the last one on question 5. I can't easily get from 16 to 64 using full powers. So if I can square root that, that will give me 4. And then if I cube 4, that will get me to 64. Okay, so thinking what we're doing there, we're going to do 64 raised to the 2/3 power. Okay, so think what we did on this one here. We had the 3 and then we squared it. So hence the 3 was on the numerator and the 2 was on the denominator. In this case, my 2 is on the numerator and my 3 is on the denominator. A good way to think about it is if I've got 64 and I raise it to the power of 1, it's going to be 64. If I raise it to less than 1, it's going to get smaller. If I raise it more than 1, it's going to get bigger. Okay, the number I want is 16, but I need to show it 64 to the given power. Now remember, 64 cubed, cube rooted is 4, and then I'm going to square 4 to give me 16. A little bit more complicated, that one, certainly for the higher tier people doing the high tier paper. Okay, there's one more that we need to look at, and that is negative indices. So if we've got 3 raised to the negative 1 becomes 1 over, the negative makes it into a fraction, 1 over, and we put that to the positive power. So the negative sign on the index means we're turning it into a fraction. In effect, we're doing the reciprocal. Reciprocal meaning we flip the fraction upside down and we raise it to the positive power. So we flip this over, that's what the negative power does to the reciprocal, and we raise it to the positive power. So if we had 3 to the negative 2, okay, we're just going to do the reciprocal, which is 1 over 3, raised to the positive power, being 2. And if they wanted us to evaluate that, we could then put that as 1/9. Okay, so let's have a look, see how we got on. If we've got 6, remember it's 6 over 1. So if we do the negative index, we're just going to do the reciprocal of 6 over 1, which gives me 1 over 6. And then we're going to raise it to the second power, the positive power that we've got. So 1 over 6 raised to the second power. If I want to evaluate that fully, I can say that's 1 over 36. B, 3 to the negative third, so negative 3. So 1 over 3 raised to the positive power. 3 times 3 times 3 gives me 27. So I can put it as 1 over 27. And the last one, if I've got 4 to the negative 2, I can make the reciprocal 1 over 4. And I'm rising the 4 to the second power, which gives me 1 over 16. Okay, so let's do one more. Let's say we've got 8 and we're going to raise that to the negative 2 over 3. Now, the steps we've done so far, we've used the multiplication, division, index laws. We've looked at fractional index laws, and we've looked at negative index laws. So what that's doing is that's combining different laws all together at the same time. So we've got the number 8 raised to a negative 2 over 3. So let's think what that actually means. So my base number is 8. I've got a negative power. Okay, we know that negative means put it as a reciprocal. So let's do that first. Let's put it as 1 over 8 of the positive power that's listed, 2 over 3. Okay. Now remember, if we've got 3 on the denominator, that means that we actually cube root the base number. Okay, and the numerator means we're then going to raise it to that top power. So the cube root of 8 is 2, so I can say 1 over 2 squared. 2 times 2 gives me 4, so 1 over 4. Okay, have we got this next one? 27 raised to the negative 2/3. Pause the video, give it a go. Okay, let's see how you got on. So the negative means we're going to raise it to 1 over 27 raised to the positive power. We're then going to use the denominator of the power to cube root it. So we've got the cube root of 27, all raised to the top numerator power. Okay, so the cube root of 27 is 3. Square the 3. Sorry, that should have been a... We're then going to square the 3 to give me 9. So my answer on this one is 1 over 9. So one thing just to note is, so far we've looked at everything and they've all been positive integers and also positive powers. So if we look at, if we had a to the negative 4, okay, and we were raising that, say timesing that by a to the positive 3, if my indices have a different number, I still do the same rule. So I still use the same base number to the negative 4 plus 3, and we use directed number or negative numbers to realise that minus 4, negative 4 to add 3 would give me negative 1. So I would raise that to the negative first power. Okay. If we look at say 2 to the 6 times 2 to the negative 4, okay, still do exactly the same process. My base number goes down. I'm going to take my 6. This time I'm going to add minus 4, negative 4. So that negative comes with the actual power. So I'm still adding because I'm still timesing my two powers together, my two base numbers together. Okay, so I'm just going to do that as 2 to the power of 2, because a positive and a negative would make a negative, so I'm going to take that away from each other. Okay, the ones to watch is when we're dividing, if we've got a to the 6 divide by a to the 4, okay, then that's straightforward. We're just going to get a to the 2. Okay, if we put that a to the negative 4, we're still going to be subtracting. So we're going to have a 6 subtract, because the divide would mean the subtract in that case, and then the negative would have to come along with that. So remember, I've got two negatives here now, and two negatives would make a positive when they're right next to each other like that. So that would end up being a 6 plus 4, okay, which is going to give me a to the power of 10. Okay, so don't fall into that trap using those negatives if the negatives are on the power. Okay, and just like if I've got a to the power of 6 all squared raised to the negative 2, my base is still going to be a. I'm still going to multiply them out, so 6 times 2 is going to give me 12, but that's going to be a negative. Okay. The only other one I would say is if you've got a raised to the negative 3 and it's all squared by negative 2. We still do the same rule, we still times them, and we do a minus 3 times minus 2, and the two negatives multiplying to each other would give me a to the positive 6. So just take care with negative indices. Okay. If you're unsure of the laws of directed number and working with negatives, check out my video listed below.